Hey there, this is Mr. Wilford, and I just wanted to introduce Chapter 3, Section 3, Solving Systems of Linear Inequalities. And if you can remember back in the last couple sections of Chapter 3, what we did was we were trying to find where two lines hit, where they intersect. And we did that a few different ways. We looked at a graph to find out where two lines hit at a point. We also did this algebraically by doing substitution or elimination, and we could find that point of intersection. Well, now what we're doing in section 3 here is we are talking about linear inequalities. And when we have a system of linear inequalities, what we're looking for really is an area or a solution where two linear inequalities overlap. So our answer really isn't a point, it's more of an area or a picture of the graph that we're looking at. You can see here in this example that both of these linear inequalities are solved for y, and they're both graphed over here, and you can use a graphing calculator for this. Let me just show you that real quick. I'll bring in the graphing calculator. And this, again, there's a link to this graphing calculator in the classroom. If you have questions with that, let me know. But basically, these are my two lines. These are my two linear equations. And if I go back to this example, we're talking about y is less than or equal to a negative 2x plus 4. So I can dial that up here. And y is greater than x minus 3. So greater than, and let me just get this in the view finder here so you can see it. And now if I click on graph, you'll notice that my lines are graphed again, and what I'm looking at for my answer really is this shaded area where both colors are overlapping. This area here is really my answer. Now if you know how to do a screen capture when you're going through and you're doing these problems, you can enter in your inequalities, your linear inequalities here. Just click on graph and then you can do a screen capture of this, and that you can submit that for your assignment. Okay, so let's go back to the problem here. So this would be the answer then. This picture here would be the answer for this problem. This is another example that's just like that. The only thing that I wanted to point out here is that we have one equation that's solved for y, and this is the blue line right here, and it's shaded above. And the thing that I really wanted to emphasize here is that when you have x compared to a number, that line is actually a vertical line at that number. So in this case, it's x equals 3 is the vertical line. Because it's less than, it's shaded to the left. My answer is where they overlap, which would be right here. And again, this would be the solution to this problem, that picture. Okay, so basically when you get to your problems for this section, a couple of these equations are already solved for y, so if you're going to use a graphing calculator, it works out pretty nice that way. However, if they're not solved for y, like number 3 here, you're going to have to solve for y first before you plug it into the graphing calculator. And then again, what we're looking for is where these two areas overlap. Just remember when you're solving for y that if you multiply or divide by a negative number, that you switch the direction of the inequality. Also down here, if you look at these bottom 4 problems, sometimes you can have 2 inequalities, sometimes you can have 3 or 4. And basically your answer there will be where all 3 or 4 areas overlap. Again, you certainly can do many of these on a graphing calculator. Alright, I hope that helps. If you have any questions, please contact me anytime. Thanks.